Go to TAPgiles.com to learn dreams, engage my services, and support the channel. This video looks at how to build variable logic for storing separate values into one variable, just like the logic used for my drawing app. So I've talked before about how to encode multiple values into one big value and then like storing that into a variable. There's a couple of extra tricks that I'd like to talk about. So let's just set up a thing. So we've got these 3 value sliders, and I'll say that they go up to 128, just out of just guesswork. Actually, they'll go up to 127, which means we have 128 values, including the 0. We're going to put this like at the bottom. So we'll add this. We'll add this in like that, and then we'll want to move it up. So we got our 127 in this slot. So there's a slot. There's a slot. There's a slot. If we multiply this by 128, it will effectively move up one slot like that. So we're putting it in the bottom slot and then shifting it up. So we can use L1 and X on here to use the modulate wire blend mode, which just multiplies this by the setting. So 128 multiplies it by 128, and now it's in this slot. And then we can add this one in. So I'll just set this to a different value, but this has the same number of values, 128 values. So we want to put this in the bottom slot, which means we just add it. And then we want to move both of these up one slot. So we multiply all that in here again by 128. And now we've got room for another one down here, and we can wire that in. And it's important these are integers so that the maths works out. So now the 24 is in the bottom slot, we've got 90 in the next slot up, and 127 in the top slot. So that's what this does. So then we have like a variable, and we set the variable, we set it constantly with that value, and now we want to decode it, and we'll do the same but in reverse, going down, and we'll like move these around to explain what's going on. So first we've got the 24 in the bottom slot, but we'd want to ignore this stuff. And here we multiplied this stuff by 128 to get over here. So if we divided that by 128, it would go in perfectly, and there'd be nothing left over. But because there's this value as well added on, then it would be, this would go into 128 perfectly with 24 left over as the remainder. So if we have a calculator and we find the remainder after division, if we divide it by 128, then we can see what that gives us. And we play time so that it actually sets this. Oh, we need this to be able to set save to the maximum value. So we'll just put a load of numbers and negative a load of numbers, and that will just save whatever's in there up to this 10 million figure. Okay, so it's storing this 2 million number, and we're getting the 24 out still though. So now if we change that, we're getting the same number out. As long as this is an integer, then that will still work properly. Then we want to divide by 128. So put that over there. Divide by 128. And we want to, so if we divided 24 by 128, it will be like 0.0 blah 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 blah. So we want to ignore this now. And we can do that by rounding down so that it ignores the decimal place, and we can just like throw that away. And then we pass that down to the next row, which would be for this one. So that's for this one. And now we can copy that down for the next row and wire that into here, like that. And if we play time, now we're getting that 90 out as well, because we're just doing the same thing. We're doing the remainder after division to ignore that to get the 90, which goes there. And then we are dividing down and ignoring the decimal down here for the next row. And then we do it again. Wire those in there. And that's getting the top one, because that's all we're left with. And it's doing like a remainder thing for up here, but that doesn't really matter. And it's also dividing down ready for the next row as if it was dividing down, but that doesn't really matter. So actually we can just go boop, boop, and that's all working. Okay, so if we set this to another integer, like 18, then we're getting 18, 56, and 127. And if this is a different integer, like 54, then we've got 54, 18, and 56, and it all stays in sync. But that's the important part, these stay as integers. So what I usually do for testing, to make testing easier, is round down and then put it in here. So then we can just like move the sliders around without worrying about if it's an integer or not. So I'll just do that. Okay, and now I can just like move these around and it all just works properly. Cool. These can also be any size you want. So let's say this one goes a lot higher, like 1270, which means it has 1271 because it includes a 0. So we need to change this one to multiply by that. So 1271. 1271. And then these need to be changed as well to, what was it, 1271? So 1271. And now it's working exactly the same. So 1154, and we're getting 1154, and these are just remaining unchanged. So now we're getting to a problem where it can only store up to the maximum of 10 million. But we're trying to save a bigger number. If we actually use a calculator, these can go up to a lot higher number. So if we wire that in there, we're trying to save 20 million, which is actually too big even for this new technique. So let me try just changing that to a slightly smaller number. To 1000, which means this is 1001. And these are as well. And that gets us up to 16 million. So we're trying to save something over 16 million, which is too big to fit into a variable, to save into a variable because it has this limit. But Dreams can actually accurately track up to 16 million. It's like over 16 million. There's a specific number, around 16 million in integers, as in like 1, 2, 3. It will precisely get those. If you halve that to around 8 million as the upper limit, then you can get halves. So it would count 0.5, 1, 1.5, and so on. So if we just divide this by 2 and then save that, we can multiply it by 2 on the other side, and it won't lose any information. It won't have any rounding errors or anything. So if we now divide by 2 and save that instead, so we're getting down to this 8 million mark, and then we multiply it by 2 over here, and use that value instead. We're just wiring it in. And now we can set that to 1000. And now we're getting the same values on the left and right again. So it's encoding it properly and decoding it. And we can now get double the numbers, double the range into this single variable by doing this halving and then doubling thing. Another thing you can do is use the negative as like a special flag, just like a single on or off 0 or 1 signal that you can slot into here as well and get out the other side. So if I just have a switch for that, if this is on, we want to multiply this by -1 so that it becomes negative. So I'll put that into here. So this will multiply it, the actual normal value, by 1 normally, and then when this is on, I'll just keyframe it to be multiplying by -1. Like that. And then we can just send this off as normal. Okay, so now we play time, and we're getting a negative number, and if this is off, we're getting a positive number. But now all these calculations will be like negative, so we need to make this positive again before. So we multiply it by 2, then we use absolute value, which means if it's negative, it turns it positive. If it's positive, it will just be positive anyway. So wire those in there like that. Okay, and now that's all working the same and getting the correct values out, it looks like. Yep. And then we can get this by seeing if this is a negative number. So if it's less than 0, then that negative sign is on, and we'll use that as another slot of data. There you go. So that's working too. The only time when this won't work is if these values are all 0, because if it's 0, 0 multiplied by -1 is still 0, so it won't be able to find anything on the other side. So for that, we can do a little bit of extra logic to give it a value if these are all 0 already. Yeah, so we'll have a chip, and we'll have like the normal full value from down here, and we'll have, do we want it to be negative or not? So wire that in there. Okay, so this is doing the same thing as it was before. If we are wanting to send a negative, it will multiply this big value by a negative. And if we don't want to send a negative, it will multiply it by 1 instead. And we'll just wire that into this output node. But if this is 0, then it will be sending a 0 to this output node. So in which case, we want to have another value kind of take over. And we can do that quite easily. So we'll have a value slider that goes to -0.1, and we'll just wire that in and then power that. Because the way this works is when multiple wires are coming in through this is the overwrite wire blend mode, and it's got like a plug icon. So it uses the value that is furthest from 0. So this is sending 0. This is sending -0.1, which is further from 0 than 0 is. So it will use that and send that out instead. So then we just put that in there like that. And now that will be sending -0.1 if we put these to 0. Oh, we need to turn that on. Now it's sending a -0.1, which is being halved. So -0.05. And then we're doubling it, and it becomes -0.1 again, which is less than 0, so it turns that one on. But then down here we want to ignore that part. So after we absolute it, we'll just round it down, which gets rid of the decimal. There we go. And then move this across again. Cool. So these are 0, but we're still getting that one flag of this bit of data here, and the rest of it still works otherwise. So that's cool. This is like a little demo that I put together earlier today of having values of different sizes. So these aren't binary, so it means we can't do that shortcut over here. So it's kind of doing it the long way. but just to demonstrate that you can actually have like lots of different size values. So like you've picked up the key, or you haven't picked up the key, or which item you have currently equipped, the skin color of the character, and how much dosh you got on you, and the level and things. And they can all have different sizes, and it just saves easily. You can adjust them as I demonstrated earlier. So this could be good for like a character in a RPG or something. Next time we'll look at an extra technique allowing us to optimize how many gadgets it needs to load these separate values, if they are all 1s and 0s. Thanks for watching. I hope you learned something interesting. Go to patreon.com/TAPgiles to learn something new every day.